Welcome to this lecture on JavaScript fundamentals. We're going to walk through the core building blocks of JavaScript, from how scripts are loaded in an HTML file, to working with the browser console, to understanding how data flows between the front end and the back end. Whether you're just getting started or looking to solidify your foundation, this session is going to give you a clear picture of how it all fits together.
Let's start with something foundational, how JavaScript files actually get loaded into a web page. Inside your HTML document, you can include JavaScript using a script tag. The position of that tag matters a lot. A script placed in the head section loads right away, before the rest of the page renders. A second script placed at the bottom of the body loads automatically after the HTML content has been parsed. This ordering controls what runs first. Now, there's an important distinction between public and private JavaScript files. A public script is one the browser can directly access and execute. It's sent to the client. A private file, on the other hand, lives on the server and is never directly exposed. Understanding this boundary is critical, especially as you move toward back-end development, because sensitive logic should never live in a public script. One of the most important topics in JavaScript is loops. At their core, all loops do the same thing. They repeat a block of code. The classic for loop gives you full control over the counter. The for of loop is cleaner when you're iterating over an array or iterable. But the one to pay special attention to is for each. It's the most expressive and readable way to loop through array elements, and you'll see it constantly in modern JavaScript code.
What makes for each special is that it takes a callback function as its argument. That callback is automatically called once for every element in the array. You don't manage a counter, you don't worry about the index bounds, you just describe what to do with each item. This is a pattern you'll encounter everywhere in JavaScript, so getting comfortable with it early makes everything else much easier to understand.
So how do you actually write JavaScript inside an HTML file? You use the script tag. Inside that tag, you can write any valid JavaScript directly. In this example, we're calling console.log, which prints a message to the browser's developer console. This is the most basic way to get JavaScript running on a page. No external files needed. It's a great way to test small pieces of logic quickly while you're learning. As your scripts grow, you'll be writing variable declarations, string operations, function calls, and more, all inside that script tag or in a linked external file. One thing to always keep in mind, JavaScript executes top to bottom, line by line, unless you use control structures like loops or conditionals to change that flow. That sequential execution model is the mental model you need to build early.
Every modern browser comes with a powerful built-in tool called the Developer Tools, and one of its most useful panels is the console. You can open it in Chrome by pressing F12 or right-clicking and selecting Inspect. The console gives you a live JavaScript environment. You can run code, inspect values, and see errors in real time. As a developer, the console is your best friend for debugging and exploration.
One of the coolest things about the console is that it's a live JavaScript interpreter. You can type an expression like 1 + 2 + 3, hit enter, and instantly see the result, 6. You can do arithmetic, manipulate strings, call functions, all without writing a single HTML file. This makes the console an incredibly fast way to experiment with JavaScript syntax and test your understanding of how expressions evaluate.
The most fundamental debugging tool in JavaScript is console.log. You call it with whatever value you want to print, a string, a number, a variable, even an object. The output appears immediately in the browser's console panel. Think of it as your way of asking JavaScript, hey, what's the value of this thing right now? It's how you trace through your program's execution and verify that your logic is doing what you expect.
Beyond basic logging, the console gives you different message types. Console.error prints in red and is used to signal that something has gone wrong, an actual error. Console.warn prints in yellow and signals a potential problem or something worth noting. And plain console.log is for general informational output. Learning to use these three together helps you communicate intent in your debugging and makes it much faster to spot issues in complex code.
Before you can do anything meaningful in JavaScript, you need to understand variables and data types. A variable is simply a named container, a place in memory where you store a value so you can reference it later. JavaScript supports several core data types: strings for text, numbers for numeric values, booleans for true or false logic, and objects for structured data. Knowing which type you're working with determines what operations you can perform on it.
In modern JavaScript, you declare variables using let or const. Use let when the value might change and const when it should stay fixed. Here you can see a string assigned to name, a number to age, a boolean to is logged in, and an object to user. Each one holds a different type of data, and JavaScript is flexible enough to figure out the type automatically based on what you assign. This is called dynamic typing.
Now let's shift to the bigger picture, how data flows between the front end and the back end. Static content means the HTML is fixed. Every user sees exactly the same thing. Dynamic content, on the other hand, is generated on the server based on data, often pulled from a database. This is the foundation of modern web applications. When you log into a website and see your name, your profile, your orders, that's dynamic content powered by back-end logic.
Here's how that flow actually works in practice. The browser sends an HTTP request to the server. The server processes that request, often querying a database for relevant data. The data comes back, typically formatted as JSON, and the browser uses that to render the updated page. JSON, which stands for JavaScript Object Notation, is the universal language of data exchange on the web. It's lightweight, human-readable, and natively understood by JavaScript.
JSON is how back-end data is structured and sent to the front end. At its core, JSON uses two building blocks: objects, which are key-value pairs wrapped in curly braces, and arrays, which are ordered lists wrapped in square brackets. In this example, we have a user's key whose value is an array of user objects. Each user has an ID, a name, and an email. This is exactly the kind of data structure you'd receive from a back-end API when building a real application. Let's break down the structure visually. The outermost curly braces define the root JSON object. Inside, the user's key maps to a JSON array, indicated by the square brackets. Each element inside that array is itself an object, representing one user record. This nesting of objects inside arrays and arrays inside objects is the fundamental pattern you'll see in virtually every API response you work with as a JavaScript developer.
Picking up from where we left off, let's talk about the three core technologies of the web: HTML, CSS, and JavaScript. Think of them as three distinct layers. HTML gives a page its structure and content. CSS handles the visual design, colors, fonts, layout, and JavaScript adds behavior and interactivity. Each one has a specific job, and together they build everything you see on the web. Here's the key distinction. HTML is like the skeleton of a room: the walls, the floor, the ceiling. CSS is the interior design, the paint color, the furniture style. And JavaScript is the electricity. It's what makes the fan spin, the light switch work, and the volume go up or down. Without JavaScript, a page is static. With it, things actually respond to the user. JavaScript is a programming language, but what kind? Programming languages generally fall into two broad categories. Low-level languages, like machine code or assembly, are very close to what the hardware actually understands. High-level languages, like JavaScript and Python, are closer to human language. They're designed for building applications. JavaScript sits firmly in the high-level, application-level category. Now let's move into one of the most foundational concepts in programming: variables. A variable is essentially a named container for storing data. Think of it like a glass of water. The glass is the container, the water is your data, and the label on the glass is the variable name. When you need the water, you just refer to the label. The actual storage happens in your computer's memory, in RAM. Here's an important insight. The variable name is just a reference. It's like renaming a location on a map. The place doesn't move, you just gave it a new label so you can find it easily. When you use a variable name in your code, JavaScript looks up that name and retrieves whatever data is stored at that memory location. In JavaScript, there are three keywords for declaring variables: var, let, and const. Var is the oldest way. It's still valid, but has some quirky behaviors, so modern JavaScript tends to avoid it. Let is the standard way to declare a variable whose value can change over time. Const is for values that should never change after they're set, like a mathematical constant or a fixed configuration value. The practical rule is this: default to using const whenever you know the value won't change. Use let when you know the value will need to be updated. And avoid var in modern code. It has scoping quirks that can cause hard-to-find bugs. This is a convention followed by professional JavaScript developers today. Once you've declared a variable, how do you check its value? You use console.log. This is a built-in JavaScript function that prints output to the browser's developer console. Notice the difference here. If you write console.log name without quotes, JavaScript looks up the variable called name and prints its value. But if you write console.log quotes name with quotes, it treats it as a literal string and just prints the word name. This is a really common source of confusion for beginners. Quotes turn something into a string, a piece of text. No quotes means JavaScript interprets it as a variable name and goes looking for that value in memory. If the variable hasn't been declared, you'll get a name is not defined error. Always pay attention to whether you're using quotes or not. Variable names in JavaScript follow specific rules. First, no spaces. JavaScript will misread anything with a space as two separate tokens. Second, names are case-sensitive, meaning first name and first name are treated as completely different variables. Third, you cannot use reserved keywords like let, const, if, or function as variable names. And fourth, names can't start with a number, though they can contain numbers.
Here are some concrete examples. First name, valid. Underscore count, valid. Underscores are fine. $sign price, valid. $signs are allowed and commonly used in libraries like jQuery. One user, invalid, starts with a digit. First name, invalid, has a space. Let, invalid, it's a reserved keyword. These rules exist so JavaScript's engine can unambiguously parse your code.
When a variable name has multiple words, so you can't use spaces, so developers use naming conventions. The most common in JavaScript is camel case. The first word is lowercase, and every subsequent word starts with a capital letter, like first name or total price. Snake case uses underscores between words, like first underscore name, and is more common in Python. Pascal case capitalizes every word and is typically used for class names in JavaScript. For everyday JavaScript variables and functions, camel case is the professional standard. So if you're naming a variable that holds someone's first name, you'd write first name, not first underscore name, not first capital N name. Pascal case is reserved for class definitions, which we'll cover later. Consistency with these conventions makes your code readable to other developers. One of the most important behavioral differences between let and const is reassignment. With let, you can change the value stored in the variable at any point. Just write the variable name and assign a new value. With const, once you've set the value, it's locked. Trying to reassign a const variable throws a type error at runtime. This is intentional. It protects values that should never change from being accidentally overwritten.
One nuance worth noting, const prevents you from reassigning the variable itself, meaning you can't point it to a completely new value. However, if the value is an object or an array, the contents of that object or array can still be changed. The variable binding is fixed, but the data it points to can be mutated. This is a subtlety that trips up many beginners, and we'll revisit it when we cover objects and arrays. Another important rule, with let and const, you cannot declare the same variable name twice in the same scope. If you write let name twice, JavaScript throws a syntax error immediately. This is actually a safety feature. It prevents you from accidentally creating duplicate variables that shadow each other. The old var keyword didn't have this protection, which is one of the reasons it's fallen out of favor. Now, let's shift to a very important data format called JSON, JavaScript Object Notation. JSONs is a standardized way of structuring data so it can be easily read by both humans and machines. It's used everywhere in web development. When a front end sends data to a back end or when a back end sends data back, it almost always travels in JSON format. Understanding JSON is essential for working with APIs and databases.
A JSON object is defined using curly braces and contains data as key value pairs. The key is always a string, it's the property name. The value can be any data type, a string, a number, a boolean, another object, or an array. In this example, the course object has three properties, a title, a price, and a boolean indicating whether it's published. Objects are ideal when you're representing a single entity with multiple attributes. Each key value pair inside an object is called a property. The key and value are separated by a colon, and pairs are separated by commas. The value's data type can vary. Strings go in quotes, numbers don't, booleans are just true or false. This flexibility is what makes objects so powerful for modeling real-world data, like a user profile, a product listing, or a course record. When you need to store multiple items of the same type, you use an array. Arrays are defined with square brackets and can hold any number of values separated by commas. A simple array might be a list of numbers. A more complex array might be a list of objects, for example, a collection of course records, where each course is its own object with its own properties. Arrays are perfect for representing lists, feeds, or search results. One critical thing to know about arrays, they are zero-indexed. That means the first element is at index 0, the second is at index 1, and so on. This trips up beginners constantly. If you have 5 items in an array, their indices are 0 through 4, not 1 through 5. When you access array data, you use this index number inside square brackets to retrieve a specific item. So when do you use an object versus an array?
Use an object when you're modeling a single thing with multiple named attributes, like one user, one product, or one course. Use an array when you have a collection of similar items, like all users, all products, or all courses. In real applications, you'll often combine them, an array of objects, where each object in the array represents one record from a database or API response.
This combined pattern, an array of objects, is by far the most common data structure you'll encounter when working with real-world APIs and backends. When a server sends you a list of products, or a list of users, or a list of courses, it almost always arrives as an array of objects in JSON format. Understanding how to read and work with this structure is a core skill in modern web development.
Now, let's dig into one of the most foundational concepts in any programming language, data types. Every piece of information your program works with has a type. In JavaScript, the main data types are string, number, boolean, null, undefined, and object. Understanding what each one means will shape how you write every single line of code going forward.
Let's start with string. A string is simply any sequence of characters, letters, words, sentences, wrapped inside either single or double quotation marks. So hello is a string, and JavaScript is also a string. The key rule is that the value must be enclosed in quotes. If it's in quotes, JavaScript treats it as text, not a number.
Next is the number type. In JavaScript, numbers cover both integers, whole numbers like 1, 2, or 100, and decimals, sometimes called doubles or floats, like 2.5 or 99.9. So if you're storing someone's age, that's an integer. If you're storing a price, like $4.99, that's a decimal number. Both fall under the number type in JavaScript.
Boolean is beautifully simple. It can only ever be one of two values, true or false. Think of it as a yes or no answer. Is this person a student? True or false? Is the user logged in? True or false? Whenever you have a condition that has only two possible states, Boolean is your data type. Beyond the basic types, JavaScript has three more that often confuse beginners: null, undefined, and object. Each one has a very specific meaning, and mixing them up is one of the most common sources of bugs for new developers. Let's break each one down clearly.
Null means intentionally empty. You've declared a variable, but you've deliberately assigned it no value. You're saying, I know this exists, but right now it holds nothing. A good example is a product price that hasn't been set yet. You might write, let price equals null. It's not an accident. You chose to make it empty.
Undefined is different from null. When you declare a variable but never give it a value, JavaScript automatically sets it to undefined. It's not that you chose to leave it empty. It's that you simply haven't provided a value yet. Think of it as JavaScript saying, I see this variable exists, but I have no idea what it holds. That's undefined. Object is the most powerful of the three. An object lets you group multiple pieces of related data together using key value pairs. For example, a person object might have a name, an age, and an email, all bundled into one variable. Objects are the backbone of how JavaScript organizes complex, real-world data, and you'll use them constantly. JavaScript gives you a built-in tool to check what data type a value is, the type of operator. You simply write type of, followed by the value or variable, and JavaScript tells you what type it is. For example, type of hello returns string, type of 42 returns number, and type of true returns Boolean. This is incredibly useful when debugging your code.
Here's a famous JavaScript quirk worth remembering. When you run type of null, it returns object, but null is not actually an object. This is a long-standing bug in JavaScript that has never been fixed for backwards compatibility reasons. So just know, if type of returns object and you suspect null, double-check your variable directly.
One of the most important distinctions to understand is the difference between a number and a number stored as a string. The value 25 as a number lets you do arithmetic. 25 plus 5 equals 30. But the value 25 wrapped in quotes is a string. If you add 5 to it, JavaScript concatenates them and gives you the string 255. This is a very common bug, so always be aware of what type your data is.
Now let's talk about arrays and how indexing works. An array is an ordered list of values. The critical thing to understand is that arrays in JavaScript and in most programming languages are zero-indexed. That means the first item is at position 0, not position 1. The second item is at position 1, and so on. This trips up beginners all the time, so it's worth drilling in early.
So if you have an array of fruits and you want to access the first one, apple, you write array bracket 0. not array bracket 1. Index 0 is always the first element. This is called zero-based indexing, and it's one of the first mental shifts you need to make when learning to program. And here's a useful formula. The last element of any array is always at the index of the array's length minus 1. If the array has 5 items, the last item is at index 4. So if you ever need to grab the last element, you can use array.length minus 1 as your index. This pattern comes up constantly in real code.
A question that often comes up is whether JavaScript supports negative indexing, like using -1 to get the last element of an array, the way Python does. The answer is not natively. In JavaScript, if you try array bracket -1, you get undefined, because negative numbers aren't valid array indexes in JS. You have to use array.length minus 1 instead to reach the last element.
Let's bring variables and data types together. When you declare a variable in JavaScript, you're giving a name to a piece of data. The type of that data, whether it's a string, number, boolean, null, or undefined, determines what you can do with it. Here, you can see a name stored as a string, an age as a number, a price as a decimal, a student status as a boolean, and an address intentionally left as null. Notice how each variable has a different type based on the value assigned to it. JavaScript is what's called a dynamically typed language. You don't have to explicitly declare the type. JavaScript figures it out from the value. But that doesn't mean types don't matter. They absolutely do, and understanding them prevents a huge class of bugs in your programs. Let's wrap up with the key takeaways from everything covered. Data types are the foundation of how your program understands and handles information. Strings hold text and quotes. Numbers handle both whole and decimal values. Booleans are true or false. Null is an intentional empty value, while undefined means a variable was declared but never given a value. And arrays always start counting from 0. Master these concepts and you'll have a rock-solid foundation for everything else in JavaScript.